Periodic inspections ensures long life. A periodic inspection of the tires is necessary to ensure a long life. The tire pressure should be checked and adjusted on vehicles that do not have TPMS. The tread area is inspected for cuts, flat spotting, or irregular wear patterns. The tread depth is inspected to ensure that it is above the built-in wear indicators, which indicate that the tire is at the end of its legal life and should be replaced. The sidewalls are inspected for cuts or gashes and any signs of damage from impacting solid objects such as curbs. At the same time, vehicles and tire manufacturers recommend that tires be rotated during each oil change. Tire balance is performed when the tires are new and anytime there is a customer concern regarding vibrations that are diagnosed to be caused by the tire balance faults, or if the tire wear indicates an out of balance condition. Wheel alignment is another service that is performed on occasion. The alignment is normally checked and adjusted in cases such as when there is abnormal tire wear, when steering and suspension parts are replaced, when the vehicle does not handle or drive correctly, and after an accident that could affect the alignment. Most tire stores will try to sell an alignment when new tires are purchased, but if the old tires were wearing normally, then the new tires will wear normally as well or also. Still, some customers like the peace of mind of knowing that the alignment was checked when they get new tires. Firestone is the only shop that gives their customers lifetime alignments. So anytime you want an alignment during a rotation, every oil change, whatever it is, they'll give you an alignment for free.
Proper tread depth is critical to maintain the safety and handling of a vehicle. Use a tread depth gauge to measure the amount of tread remaining on a tire. When measuring tread depth, make sure the blade of the measurement tool is not on one of the tread wear bars. This will affect your measurement. Place the tread depth gauge across the tread of the tire with the measuring blade of the tread depth gauge into one of the grooves of the tread. Press down on the center of the tread depth gauge so the blade goes down into the tread. Remove the gauge in order to measure the tread depth. The tread depth gauge measures in 30 seconds of an inch. Look at the gauge where it slides out of the body. Note that the line just below the 4 is even with the body of the tool. The depth of this tread is 4 30-seconds of an inch. Make sure you measure in a minimum of 3 spots across the tire.
Everybody signed in?
Use the lowest measurement as your tread depth. The legal tread limit is 2 30-seconds of an inch in most states. Wet and snow traction will be greatly diminished at 2 30-seconds of an inch. In snowy and wet climates, typically 4 30-seconds to 6 30-seconds of an inch of tread depth is recommended. If the tread depth varies considerably between measurements, that indicates an abnormal tire wear pattern. Consult the service information or inform your supervisor to determine the cause.
Proper tire inflation. The tire inflation pressure is the amount of air pressure in a tire that provides it with load carrying capacity and affects the overall performance of the vehicle. Vehicle manufacturers determine that the tire inflation pressure based on the vehicle's design load limit, which is the greatest amount of weight a vehicle can safely carry, and the vehicle's tire size. The proper tire pressure for the vehicle is referred to as the recommended cold inflation pressure. It is measured in PSI or kilopascals. You will find this information on the tire placard expressed in PSI or kPa. The tire placard can be located on the A or B pillar door frame, in the glove compartment, or in the fuel filler cap. Because tires are designed to be used on more than one type of vehicle, tire manufacturers list the maximum safe inflation pressure on a tire sidewall. This number is the highest amount of air pressure that should ever be put in the tire. The maximum tire pressure should never be exceeded, even when the vehicle's tire placard indicates a higher pressure. 32 psi of air pressure can generate over 50,000 pounds of force on a tire. If the maximum tire pressure exceeded, the force from the air pressure generates even greater forces and can cause the tire to explode violently. A lot of young technicians have lost their lives when overinflated a tire blew it up in their face. This is one of the more dangerous situations for inexperienced technicians. It is also why it is good to use a tire cage when inflating a tire. If the tire blows up, the explosion will affect the hearing, but the cage is likely to contain most of the tire debris. To get an accurate pressure reading, the tires must be checked when cold. The term cold does not relate to the outside temperature. Rather, a cold tire is one that has not been driven on for at least 3 hours or less than a mile. While driving tires can get warmer due to heat of friction created by the tire's materials flex against each other. As tires rotate and the sidewalls flex due to variations in the road surfaces, they generate heat as layers of plies are forced to accommodate the sidewall flexing. Flexing results in heat.
The sidewalls of radial-ply tires bulge where the tire meets the road, making it difficult to establish inflation pressure visually. It needs to be checked with an accurate tire gauge. Using correct inflation pressures extends tire life and is vital for safety. Sidewalls of an underinflated tire flex too far, which pushes the center section of the tread up and away from the road surface. This causes wear at the shoulders of the tire. In an overinflated tire, the sidewalls are straightened, which pulls the edges of the tread away from the road and causes wear at the center of the tread. A tube-type tire uses an inner tube, which provides an airtight container inside the tire. A tubeless tire is lined with a soft rubber layer to form an airtight seal. This inner liner also seals against small penetrations, letting air escape only relatively slowly. When a tubeless tire is fitted, an airtight valve assembly is used. It can be a tight fit into the rim or be held with a nut and sealing washers.
Nitrogen fill. Oxygen is harmful to rubber and tire materials. It reacts to the rubber through oxidation, loss of flexibility and sealing ability, degradation over time, pressure loss as inner liner oxidizes. Leaking results from rust and dust, but nitrogen reduces these problems. The advantages of nitrogen film: it permeates rubber at a slower rate, is far less reactive, does not cause rust, corrosion, or degrade the rubber. It gives a higher tire efficiency at correct pressure, better maintains performance, increases fuel efficiency, and reduces accidents. Air is about 78% nitrogen and 21% oxygen and 1% other. Nitrogen levels must be at least 95%, 2 or 3 inflations per deflation. The green valve stem caps indicate its nitrogen. Manufacturers do not mandate nitrogen use based on its ability to better retain consistent pressure. And tire rotation patterns, removal and relocation of each tire wheel assembly. It promotes a uniform wear, it extends tire life, and boosts fuel economy and performance. It's recommended every 5,000 miles or every oil change. The rotation sequence depends on a front, rear, or all-wheel drive, and types of tires, and if the spare is involved. And a 4-tire rotation with non-directional tires has one of 3 rotation patterns. It's a forward cross, a rearward cross, or an X pattern. Here you see in little pictures up here in the left, starting with A, is a forward cross pattern. The B is the rearward cross pattern. C is an X pattern, and the front to rear pattern. E is side to side pattern from the other side of the vehicle. F is the 5-tire forward cross pattern with the spare tire. 5-tire rearward cross pattern. Wheel balancing. Wheels and tires are mass-produced so many times that they are small or sometimes big imbalances manufactured into them. Also, they are not always perfectly round, but they can still be sold as long as they are within the tolerances specified by the manufacturer. To complicate complicate matters, tolerance stacking can happen. If all the tolerances are stacked up, that's one on top of another, then the wheel will experience a balance and run out issues. Wheels and tires that are not balanced or that they are out of balance generally produce an uncomfortable vibration and result in premature wearing of suspension, steering components, as well as uneven tire wear. An out of balance tire will cause the vehicle to vibrate at certain speeds, usually between 50 and 70 miles per hour. A tire is out of balance when one section of the tire is heavier or stiffer than the others. 1 ounce of imbalance on the front tires is enough to cause a noticeable vibration in the steering wheel at highway speeds. There's 2 ways the wheels can be balanced on or off the car. Although most shops use off-car balancers, if the brake rotor drum or hub is out of balance, then a balanced wheel cannot compensate for that. So an on-car balancer is used to balance the entire rotating assembly. The only problem with on-car balancing is that the wheel will need to be rebalanced when it's rotated to another position of the vehicle. This is one of the reasons why most shops use off-car balancers. Tires and wheels can be balanced in 3 ways: static, dynamic, and road force. Static balancing. With static balancing, the tire's imbalance is measured when the tire is stationary. Static balancing does not take into consideration that the tire has a width, and static balancing can address the imbalance only as it relates to how much weight is needed to counterbalance the imbalances X inches away from the center of the axle. Static balancing assumes that the balance is centered across the width of the tire. Therefore, it can be effective only when dealing with an imbalanced condition that is centered within the width of the tire. Static imbalance tends to cause the tire to move purely up and down. Static balancing is no longer an acceptable method of balancing in tires of today's vehicle. Dynamic balancing is performed when the tire